In UniFi network controller, if you go to security and general, you can see this option, internal honeypot. If you check the tooltip, it tells you it's to find a malicious client on the network. You may wonder what it is about and how it can even find a malicious client on Earth. Let's look into it in this video. This Wikipedia article explains what's honeypot in the context of computer security. So it's a mechanism to detect, deflect, or even counteract attempts at the unauthorized use of the IT system. And the main use for this type of decoy is to distract the attackers from more important information, and it can even learn the attacks and examine the attacks. Let me create a test honeypot in the UniFi network controller. Create new. For network, let me choose VLAN 10. For honeypot IP, let me provide a fake IP address within the subnet of VLAN 10. So let's say .10.88. Create. Okay, it's done. Super simple, right? It doesn't tell you what really happened, and it even doesn't tell you what if this honeypot is attacked by someone. Let's see it in action. In the lower right of the screen, I have a Linux virtual machine within VLAN 20, not within VLAN 10. So let me use it as a machine for the attacker. Try to connect to the honeypot IP address. Let me first try, let's say, DNS. What I'm saying is, let me use this honeypot IP address as the DNS server. Try to resolve x.com. Do it. The dig command just hang there. It will try 3 times. Each time it will return timeout error. So the symptom is just like you are trying to use a non-existing DNS server, right? But let's see whether internally within the system, whether it has any other things captured. Later we will check it. So we try DNS. Let me try telnet, for example. So let me try to telnet to this honeypot IP address. See, amazingly, it's connected and it's showing the normal prompt for telnet. But here, whatever I use, it will return the login incorrect error and the connection will be closed. We just tried 2 different things, right? For DNS, it just seems that machine doesn't exist. For telnet, it seems that machine is running telnet, but it doesn't really allow me to log in. Okay? You may know for honeypot, the way to detect something happened to warn the user is to check the system logs. In UniFi network controller, let me go to system logs. And at the top, you see multiple log types, right? But I don't see anything for honeypot. Apparently something's wrong here. The real reason is Ubiquiti first doesn't explain how to enable the honeypot logs in the display. Secondly, Ubiquiti has a confusing user interface design. It mixed the honeypot logs with the security detection logs. Let me show you what I mean. Now you don't see honeypot logs, right? But if you go to settings again, under security for intrusion prevention, now it's showing off, right? Let me set it either advanced or auto. It doesn't matter. It's enabled. Now let me go back to system logs. See, all of a sudden there's a new tab. It's called security detections. And if I click on it for today, there are already 3 logs showing here already. And if you check the filter, Ubiquiti even lists 2 types of logs under the security detection, honeypot security detections. Ubiquiti should have split these 2 types into 2 different tabs. Hopefully Ubiquiti can correct this confusing design in the future. But now at least we can see our honeypot logs. So let's examine them one by one. So let's see the first one. The service is domain, which means DNS. That's the result of our first try. And then the second thing, again, is domain. Again, DNS. The third thing, again, DNS. The reason we didn't see the logs for telnet works, it needs some time, maybe even 1 or 2 minutes delay. After refreshing the system logs, now I see 2 additional entries. So let's see them one by one. The first one, telnet. The second one, again telnet. I assume the first one was for the initial connection, and the second one was for the interaction that I input some username password and the system disconnect the connection, right? That's why we see 2 logs. But anyway, for the 2 testings we did, DNS and telnet, the system captured the activities in both scenarios, created multiple logs accordingly. So now we see how it works in action. You may be interested how this is even implemented in backend. Where is this non-existing Honeypot IP address even able to provide service such as telnet, right? And why the system can detect the connection and log something. So let's explore how it's implemented in the backend inside the UniFi gateway. Let me SSH into the UXG Pro. I'm in. First, let me see whether the Honeypot IP address is being served by the gateway. So let me check the gateway's IP address. See the very last one, Honeypot 10. 10 means VLAN 10, and it has this IP address, just like what we set in UniFi Network Controller for Honeypot, right? So this proves the gateway itself is faking the IP address for Honeypot. If we check the device details for Honeypot 10, ifconfig Honeypot 10, yeah, it just behaves like a regular interface in Linux. If you want to know what this Honeypot 10 is exactly, in fact, it's a virtual interface defined in Linux. If you use /tool to display the information, you can see it's a dummy interface. It's created by UniFi in the Linux operating system as a decoy. And let me see what process is listening on this IP address within the gateway. Let me run netstat. I'm only interested in this Honeypot IP address. See, it listed totally 9 entries for 9 different ports. In the slide, I also listed the 9 different ports. You can see only one is for UDP, which is DNS. All the others, they are for TCP. And in the most right side, you can see what process is listening on the IP address. The process name is called UTM daemon. So if you want to see what this process is, let me run UTM daemon help. You can see this is developed by Ubiquiti. Apparently, it's faking all the 9 different services. Now we know how the system even pretend there is a machine with that Honeypot IP address. That's a result of this UTM daemon process. But there's one thing still not clear. It's about how the system even allowed the connection to the Honeypot IP address. If you check the firewall rules, go to security, firewall rules, you cannot find anything related to that Honeypot IP address. You may wonder, what if you define some firewall rules which drop the connection to VLAN 10 machine? Does that mean the Honeypot won't be working anymore? So apparently there's something else being implemented in the backend that has to be in IP tables. Before we check the details of the IP table contents, let's see what additional modules are loaded to Linux kernel to support IP tables. The reason I want to check it is for this type of special implementation, normally some custom modules are needed to support the additional functionality within IP tables. So let me check what are the current loaded extra modules. Here we see the dynamic random, which is related to load balancing for one part. We see the connection track. We see all the familiar set information, but there's one thing which is related to this video. It is multipart. Remember, we mentioned there are totally 9 parts being faked by the Honeypot machine, right? It is using the custom module, which is called Multipart. If you want to know what's Multipart for, let me try to run IP tables for the Multipart module. See the very last section, Multipart match section. Basically, it can match multiple parts. You may know for standard IP tables, you can easily match source part, destination part, but you can only list one part. But here we have 9 parts. Apparently for performance reason, Ubiquiti chooses to load a custom module which has name Multipart to support matching the 9 possible parts in one rule instead of 9 individual rules. That's why Multipart is even being used here. Now it's time for us to see how the IP tables are used to make the connection possible. So you may know there are 3 tables for IP tables. Filter is corresponding to our familiar firewall rules, and the net is for SNet, DNet, and masquerade net. So let's first check filter table. There are a lot of rules, but the ones which are related to our video is here. Input jump, and the first chain is called Honeypot filter. The second chain is called input user hook. If you check the input user hook, you may understand they are corresponding to our firewall rules listed here. You can see the Honeypot filter is ahead of the regular firewall rules filter, which means no matter what you define in the future in the firewall rules in UniFi network controller, the Honeypot filter will always take priority because it's always being executed before your firewall rules. So that's why the Honeypot setting won't be impacted by whatever firewall rules you define. Okay, let's see what's defined exactly within the Honeypot filter. It's defined using Honeypot input, and Honeypot input is here. It has 3 rules. The first rule is to allow DNS. Domain means DNS means port 53. Okay, the second rule is to allow, see here, the multi-part we just discussed, the destination parts, as long as it's one of these parts. And the third rule is the default rule, which is drop. For Honeypot, it support and only support these 9 hard-coded port numbers. You may already see it doesn't include the, let's say, HTTPS. It doesn't include many port numbers you wish they are captured, right? Because the Honeypot is completely a custom implementation. Ubiquiti can choose what port number it will capture. But I wish Ubiquiti had a better documentation telling the users what parts are being captured. But here in backend, you can see it by yourself. Okay, so this filter IP tables explains how the 9 parts access are even enabled, why the firewall rules won't override them. But I'm not sure whether you observe one problem, which is these 2 parts, 8000 and 2222. You may wonder what are these 2? Why these 2 are listed? Why we don't see the familiar 80? So then we need to check another IP tables, which is net table. Let me still run IP tables command, but display the net table instead. The Honeypot related part is called Honeypot pre-routing. It's very simple. Just 2 DNet rules are included. The first one is a DNet. As long as the destination is the Honeypot IP address, as long as the destination port is SSH, which is 22, it will translate the port to 2222. As long as the destination port is HTTP, which means 80, it will translate it to 8000. You may not understand what's the need for these 2 seemingly unnecessary translations, right? The reason is here we are talking about something running within the gateway. You may know UniFi gateway provides HTTP service for you to connect to the gateway using web browser directly, and you can use SSH to log into the backend, right? Just to avoid conflicts with the existing real service, Ubiquiti used DNet rule to translate the destination port to something else. That's why here for the 9 parts it support, you see these 2 strange numbers, because what they are really for is for HTTP and SSH. I hope now it's clear. Just to validate it, let me use curl command in the VLAN 20 machine accessing the Honeypot IP address. Okay, it will wait here until it's timeout. Okay, it's just waited here forever. I don't want to wait. Let me kill it. Then let me run SSH. Okay, the same effect. It just hang there forever. Kill it. Let's wait for some time. Then let's check whether we have any system logs for these two malicious activities. Okay, I do see several new logs. Let's start with this one. Yes, see this one is for HTTP service. The port number is 80, but internally the DNAT rule translated to 80000, right? Then the next one, again, it's 80. I guess it's internally the curl command made the second try. That's why we have another log captured. Then move on. See the very last one is for SSH and the port number is 22, but internally DNAT rule will translate it to 2222. Okay, so basically the Honeypot functionality is implemented using 4 different parts. First, it used the Linux functionality, created a dummy interface just to fake the Honeypot IP address. And internally, Ubiquiti use UTM daemon to fake the services for the 9 different parts. If someone tries to access them, the process will make the system logs. Then it used the IP tables, the filter table, to override whatever potential future firewall rules. It used the DNAT rule in IP tables to translate the HTTP and SSH to these two strange numbers just to avoid conflicts. Okay? By the way, you don't see ICMP protocol is listed here by Honeypot, and even if you try to ping the Honeypot IP address, the effect is exactly the same thing as the IP address doesn't exist. Why is that? Because remember in the IP tables, the third drop rule, because the port number and the protocol don't meet the condition, so this ping packet will be simply dropped. And from Honeypot logs, you won't find your ping access, right? Let's move on to next topic about the choice of the Honeypot IP address. So here in this video, I choose this random IP address as an example. In real world, when you want to choose the IP address for the Honeypot, there are 2 different scenarios. First scenario, you know someone is trying to hack a particular IP address. Then you can set up a Honeypot using that IP address. For example, this 10.88. But most common scenario is you don't know. It's just something you want to set up to capture the potential future malicious attacks. If that's the case, you can choose whatever free IP address. The reason is normally the hacker will do port scan. They will scan a range of IP address. Let me show you. So let me use the popular nmat command to do the scanning. And here I'm saying I want to scan this range of IP addresses. You can see our Honeypot IP address is within this range, right? Let me run it. It's completed in just 2 or 3 seconds. Only for 88, it reports something back. All these services exist for this IP address. This is the information the hacker can get from the Honeypot. And because the hacker did the malicious activity, let's go to the system logs in UniFi network controller. Let's see what we captured. A lot of activities were already logged. So starting from this one is for HTTP, then SMTP, POP3, Telnet, HTTP again, FTP, SSH, Microsoft DS, HTTP, SSH, Microsoft SQL, HTTP. This is what we can observe if someone scans the ports on the Honeypot IP address. Okay? Before ending this video, let me talk about 2 special cases. First, for this green bear, as you can see, it's in VLAN 10. You may know if we are talking about the firewall rule, the same VLAN access won't be protected by firewall rule because the traffic won't go through the gateway, right? But for this Honeypot situation, it doesn't matter whether the hacker's client is within the same VLAN or not. In the left side VLAN 10 machine, let me telnet to the Honeypot. You can see I can connect to it just like in VLAN 20. So for this particular case, it will still work. But for this red bear case, it's from the internet. From internet, it cannot directly access the IP address for the Honeypot. It has to access your OnePart's IP address, right? So for this case, the Honeypot won't work anymore. The reason is, if you check the Ubiquiti setting carefully, let me go to the Honeypot setting. See the label for the functionality? It's internal Honeypot. It's not external. It's not for internet purpose. So someone may ask, then what if I want to see whether from internet someone's scanning the parts for my gateway, or whether you have any malicious activities on your OnePart? For those type of activities, you have to rely on the regular intrusion protection functionality. For UniFi gateway, it won't be implemented by using the internal Honeypot. Okay, I hope it's clear. This ends this video. Thanks for watching.